Hello, everyone, and welcome to another video. Well, today we will be taking a look at the new channel called The End of Space, which is a very provocative title, of course. And essentially, this is about the whole Mikey Smith and flat Earth reconnaissance thing. You may have recognized that there's something going on. It involves telescopes and all this sort of thing. So we will be talking about that today. If you're wondering where I've been and what's been going on with me, there is a small little update section at the end of this video, so stick around if you're curious for that. I might put a timestamp here right now for if you are only interested in the update section, or if you want to skip it for that matter. All right. Um, Essentially, what this is on about are the observations that Mikey Smith has made with his binoculars that he stuck his phone, I believe, as a camera onto and has made pictures. Now, I've made pictures in the past with the same method, only using my cheap, small little telescope and not a pair of binoculars, but this is a very reasonable method to take photos, albeit, of course, the quality of the photos will be quite low. Unfortunately, though, Mikey Smith and companions, most foremost Flat Earth Reconnaissance, Sam, I believe his name is, they seem to misinterpret these pictures quite severely. For example, here is footage of Sirius 3, or of the of Sirius from the third kind of thing that Sam I just mentioned. And so essentially what they have going on here is an out of focus star with some lens defects or optical defects, as we call them in astronomy. So this is essentially what's going on here, and I would like to talk about that for a little bit today. So essentially what you're seeing here is this is the image of a star as seen in high zoom with a non-adequate observation setup and probably equipment. I'm aware that Mikey Smith uses very expensive binoculars because for some reason he says that with telescopes he can't see this, which should already point you to the fact that maybe what's at fault here is your equipment and not that you're discovering something new. Just a small little hint. And essentially, what you see here is a lens defect, right? Lens defects, for example, in this case, he talks about the rainbowing of Sirius 3, the rainbow reflection, which is he actually discovered a genuine optical phenomenon here, right? Where you can see that the quality isn't exactly the best, but you can see here it's blue, and up here it's more white, and up here you can kind of see a hint of yellow, not exactly in this frame, but it does do a little bit of a rainbow, right? And that's something that we call a chromatic aberration. This is a very well-known lens defect. This is due to the fact that different wavelengths of light interact differently with materials. So, for example, the blue light will be refracted more strongly as opposed to, for example, the red light, meaning that the ideal focus point for the blue light, is not at the same place where it would be for the red light. And so what you get is, for some observations, you get what we call chromatic aberration, an extreme case of which you can see here, for example, where on the right-hand side, chromatic aberration is not really present, at least not obviously. And on the left-hand side of this division in this image, you can see that outside the things are red and inside they're kind of greenish. And this goes true for essentially the whole rainbow if you want. Then you may ask, why don't we see blue here? That's because there's very little blue in this image to begin with, right? I do even have an image of myself that I will show at a later point, where you can see this effect pretty nicely, right? And so this is essentially what this is here, right? You have the blue down here, and you have the other things up here, the more different colors. And something that you can also see is the shape is all off. Why is there like a point, almost a sharp point? Well, this has to do with their specific equipment, and this is something well known. For example, here you have the OVLA telescope, before on the left hand side and after the astigmatism correction that was carried out in the mirror. There are whole papers about this. Astronomers know about this very precisely, and you can look things up, right? This is nothing new. We are being taught these things in our university courses, in the bachelor's course, in our case in a subject called in a course called astronomic instrumentation, right? This is nothing new. Yeah, I should maybe mention at this point, if either Mikey or Sam or someone else from their gang sees this. Hi, I'm Olaf. I'm an astronomer. I have a master's degree in astronomy and a master's degree in physics, and I do corrections here on YouTube for this exact sort of stuff. And so what you can see on the left hand side is before the astigmatism a correction that was made, and you can see that the star looks a lot bigger. But this is not inherently because stars have visible structure like that or something like that. Although I can see how you arrive at this conclusion a little bit, at least. This is because of the way that the lens and all of the other optical elements that you have inside of your telescope or your binoculars, they are slightly imperfect. And so light doesn't always travel in exactly the way you want it to travel through a telescope, right? And I will show you this and a few other effects from pictures that I took yesterday when I was out observing with my telescope. But this is something very well known, and this image on the right here, this little point, although it is very nuanced here, it's of course a lot stronger in non-professional equipment, which is completely fine, by the way. I'm not faulting them for doing that, although they could have put it in focus. This is out of focus. So yeah, what the thing that's going on here is that essentially you have lens aberrations or lens defects, as we call them. And there's a very nice guide here from lonelyspec.com. That's an astrophotography website that goes through all of the aberrations quite nicely. For example, here we have another case of chromatic aberration, although this is very weak here, where you can see that the colors kind of behave differently depending on where you go with this. And this is because the light travels differently a little bit depending on wavelength throughout all of these lenses. I'm aware that they use binoculars. This is just an example, but the principle holds the same. This is a good example of chromatic aberration here, right? If you look at the white point, one side is going to appear reddish and the other is going to appear bluish, and depending on which color your point has in the first place, of course the blue may not be blue but green if it contains a lot of green light, for example. And you can see this here, for example. Here, because there is more green present than red, this side here looks green and the other side looks almost violet-ish, right? Those are all very classic cases, and we can correct for them in astronomy software. There's another one called spherical aberration, although this is not the point I'm trying to make here. And the other one that they have, of course, is astigmatism. Not a tangential or sagittal case, like a very specific case, but kind of all over the place, mostly stemming from non-professional equipment, which again is fine. My own telescope does that, although I have a very cheap 70 euro telescope. This is what this can look like with more expensive equipment. But as you can see, this gives you these points here, these needle, almost like needle like impressions. And there are a whole bunch of other things, and even a aberration test chart that you can have a look at and see if you find some of your own lens aberrations here. For example, the coma and astigmatism are very common combined, and this gives you these weird looking things that I think don't look dissimilar from what we can see here, right? Exactly. Real astronomers correct images in a very certain way, right? We did that in university, for example. This is from Astrobasics. This is a one website that tells you a little bit about this. We correct them in this way. We take dark frames, bias frames, and flat frames. Darks essentially being an image of the sky where there is nothing there that this telescope can see. A bias is when you put the object, like the what you call it, like the lid on the telescope. Can't think of the name right now in English. the lid, if you want, on the telescope, and you take a picture. So the bias kind of reads out what your detector is doing behind the scenes. The dark reads out what your field of view is at, kind of, if you want. For example, in this case here, you have some source shining light into here. This could be from ghosting due to something, due to sensor, exactly sensor glow, as it's here the case, and things like that. And then we take flat frames that are of flat frames of fully white, right? And then we do all kinds of fancy maths with them in order to correct a picture as much as possible. You can see here, for example, that there are lines, like horizontal lines in the detector. And this is the detector recording absolutely nothing. There is nothing there. This is just something the detector is doing. And you need to correct for all of these things on top of making sure that the observation is fine in the first place, and that the telescopes has as little optical defects or lens defects or aberrations as possible. Right, so you really need to look at all of that, and if you do that properly, you get one of these pictures. This is a picture I took with the telescope of our university, and this is NGC, I think 2291, unless I'm mistaken. And as you can see here, and this is not for me to brag, this is very bad astronomy photography thing. Like this is not a good example for astrophotography. I'm just showing you that this can be done relatively easily, right? Where you can see here is NGC 2291, and you can see there are almost no lens defects here on the surrounding stars. I'm showing this because of the stars, although the galaxy, of course, looks cool. And the only thing you can see is strong spherical aberration, but this is because if I wanted to see that star, I would have put down the observation time, like the integration time in the sensor, quite a lot. This is well overexposed, but the galaxy is nicely exposed. And the smaller stars, like this one here, for example, they just appear like a dot. And this is what stars are meant to look like. And this is because if you don't have them look like that, you're not in focus. If your star appears significantly bigger than that, it's not in focus. And I would like to show you something. Maybe issue a little bit of a challenge, such that you can see what you did wrong. All right, on screen now, you can see 3 different types of stars, A, B, and C. Well, actually, only one of them is a star. The other 2 are streetlights. Streetlights I took a picture of with my telescope and my phone attached to it from a good kilometer away, such that it would appear as a point source. I've only changed the saturation and the contrast, and adapted the colors a little bit, because otherwise it would have been very obvious which one which one is the street light and which one isn't. And so these 3, as you can now see here, A, B, and C, one of which is an actual star, the other 2 are streetlights, and you can see all of the defects in them, right? You can see chromatic aberration, you can see, to a certain degree, you can see astigmatism, you can see spherical aberration, all of that, all of the lens defects that are in here. Don't get me wrong, Mike or Sam, if you're watching, I fucked this up on purpose. Pardon my language. I messed this up on purpose. This is not how things are supposed to look like. They are wrong. I made them look wrong. You could see that it was a street lantern if I hadn't gone out of focus and if I hadn't chosen a very suboptimal settings on my camera sensor, on my phone, really. Right? So, and I will not solve this in this video, which of them is the star. If you can tell, I mean, you're definitely still not onto something, because this is a well-known and explained phenomenon in astronomy, but at least you know. Right. So let me know which one you think. All right, what you can see here is a video I took of the moon. As you can see, it is very nice and focused in the beginning, but then I, on purpose, changed the focus such that it gets blurry. Not only does it get blurry, you can also see chromatic aberration in yellow, and you can also see chromatic aberration in purple, or magenta, just a little bit later. And I'm doing this because I would like to show that the things are in focus if they are the smallest. That's when they're in focus. So if you can change the focus on your telescope or on your binoculars, and it appears to be smallest at one setting, this is what the setting you should choose is. This is where it's in focus. This is the sharpest it can be. This has to do with how light travels through your binoculars and with your telescopes. And essentially, when they come together to a point, two different two different kind of light paths of a point, this is where you're in focus. And any other place, you're out of focus. So really, and I'm not trying to talk down to you with, oh, I'm an astronomer and things like that, although I am. Um, you're just making rather simple mistakes when handling your telescope and your equipment in general, and making huge, and I mean monumental, conclusions from that. You have a very big claim and you have no supporting evidence. And this is something that I'd like to bring to your attention here. All right, and now for the small channel update. First of all, thank you so much for bearing with me. I've only lost 2 subscribers over being gone for like half a year. I do beg your pardon for that. This is on the one hand because I think the content in Flat Earth has dropped significantly. It has dropped down a cliff as far as I'm concerned. I have been on the lookout a couple of times, but I can't really find new, interesting, and really funny things other than, oh, there's an observation that shouldn't be possible, and then I have a brief look into it, and oh, they're not taking refraction into account. Well, that's it. And I find these observations, I mentioned that previously, I find these observations to be very much non-indicative anyway. They are most of the times agreeable with both models if you factor in that no one did any temperature measurements, and thus refraction is essentially a big unknown. So, regardless. Things have been going on in my life, of course. We have resubmitted our paper. It's currently, as of the release of this video, still in review for the second time. We received very, very, very extensive comments on our first draft, more than 20 pages on our 11-page paper, or 10-page paper, I believe. So very, 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 very extensive. I was very busy with that. I also finished my second master's degree. I am now a master in physics and in astronomy. I have had the exam last week, I think, when this video goes up, in my physics master's. I may do a video explaining what I did in my physics master's. When the paper is published, I will also do a video explaining what my research kind of is about. In other very big news, I have been offered a PhD position at a university in the United Kingdom, which I have accepted. I will be moving to the United Kingdom in October, and I plan to continue doing video of the sort and maybe a little bit more educational over there. Yeah, and that's it from me. I hope now that I have finished all of my things, I hope that I can do a little more videos, maybe 1 or 2 streams if something interesting pops up. If you want me to have a look at something, feel free to drop me an email or comment it down below, and I will be sure to have a look. All right, with that, I thank you very much for watching. I hope you enjoyed this video. If you did enjoy it, maybe consider leaving a like. If you enjoyed it a lot, maybe considering subscribing. Yeah, and I will see you hopefully in the next video and or stream. Until then, have a nice time. Goodbye.